One island, 23 million people, smaller than the state of Maryland, and they control 92% of the world's most advanced computer chips. Not some of them, 92%. If production stopped on this island tomorrow, the entire global economy would collapse within weeks. Your iPhone has a Taiwan chip inside, your car's computer systems, Taiwan chips, your laptop, Taiwan chip. The massive data centers running AI, cloud computing, Netflix, Google, everything, all powered by Taiwan chips. Modern civilization as we know it cannot function without this one island. And here's the terrifying part. China claims Taiwan as its territory and has repeatedly threatened to invade and take control by force. If that happens, the United States has said it would defend Taiwan militarily, which means the risk of World War III exists partly because one island makes all the chips that run modern technology. This isn't an exaggeration. Military analysts call Taiwan the most dangerous flashpoint in the world. How did this happen? How did Taiwan, a small island with no natural resources, no oil, no special geographical advantages, become the single most important place in the global technology supply chain? The answer is one company, TSMC, Taiwan Semiconductor Manufacturing Company. TSMC makes the processors for Apple's iPhones, NVIDIA's AI chips, AMD's computer processors, Qualcomm's smartphone chips, and basically every major tech company on Earth. They don't design the chips themselves, they just manufacture them. But they're so far ahead of everyone else technologically that no one can compete. Intel, the company that dominated chip manufacturing for decades, tried to catch up and failed. Samsung has poured billions into competing, and they're still years behind. China has spent over $150 billion trying to build their own advanced chip industry, and they can't do it. TSMC has a monopoly on the most advanced semiconductor manufacturing in the world, and that monopoly makes them the most strategically important company on the planet. More important than any oil company, more important than any bank, because without TSMC, the entire digital world stops. But this wasn't luck. This was deliberate strategy executed over 40 years. Massive investment in research and development. A revolutionary business model that no one else saw coming. And relentless focus on being the absolute best at one thing. Taiwan went from a poor agricultural economy in the 1960s to controlling the most critical technology in the world today. And now the entire planet is economically dependent on what happens to this one island. So how did Taiwan do it? How did TSMC build an unbreakable technological monopoly? And what happens to the world if China invades? In this video, I am breaking down exactly how Taiwan became the chip-making capital of the world and why that makes them the most geopolitically important place on Earth. Let's get into it. Before we talk about how Taiwan dominated semiconductors, you need to understand what semiconductors actually are and why they're absolutely critical to modern civilization. A semiconductor, or microchip, is essentially the brain of every electronic device. It's a small piece of silicon with billions of microscopic transistors etched onto it. These transistors process information, perform calculations, and control everything the device does. Your smartphone has multiple chips inside. One runs the operating system and apps, another manages the camera, another handles wireless signals. Your car has dozens of chips controlling the engine, brakes, navigation, and entertainment system. Modern cars have more computing power than the spacecraft that went to the moon. Even simple appliances like refrigerators and washing machines have chips inside controlling their functions. And the most advanced chips, the ones Taiwan dominates, power the technologies that run the modern economy. Data centers running cloud computing and artificial intelligence use thousands of these chips. The entire AI revolution, ChatGPT, autonomous vehicles, advanced robotics, all of it runs on extremely powerful chips that can process massive amounts of data at incredible speeds. Here's the critical part. Not all chips are the same. Simple chips for basic electronics are relatively easy to make. Many countries can produce those. But the most advanced chips, measured in nanometers, only a handful of companies can manufacture. And TSMC makes 92% of them. Advanced chips are measured by their process node. The smaller the number, the more powerful the chip. Right now, cutting-edge chips are 3 nanometers. A human hair is 80,000 nanometers wide. TSMC is etching transistors that are 3 nanometers across with billions of them on a chip the size of your fingernail. This is insanely difficult. It requires machines that cost over $150 million each. It requires perfectly controlled clean rooms where a single speck of dust ruins the entire production. It requires decades of knowledge and expertise that cannot be copied overnight. This is why China has spent over $150 billion trying to build advanced chip manufacturing and still can't do it. This is why Intel, who invented much of this technology, fell years behind. This is why every major tech company, Apple, NVIDIA, AMD, Qualcomm, all depend completely on TSMC. Without advanced chips, there are no AI breakthroughs, no faster phones, No better computers, no advanced medical devices. Technology progress stops. And TSMC, the company that makes these chips, sits on an island that China claims and threatens to invade. That's why Taiwan matters more than almost anywhere else on Earth. But Taiwan wasn't always a technology powerhouse. 60 years ago, they were a poor agricultural island with no chip industry whatsoever. In the 1960s, Taiwan was poor. The GDP per capita was around $200 per year, lower than many African countries. The economy was almost entirely agricultural. Rice farming, sugar production, basic textiles. That was it. Taiwan had no natural resources, no oil, no valuable minerals, no technology industry, nothing that suggested they would become a global tech leader. And they had serious geopolitical problems. In 1949, the Chinese Civil War ended with communists taking control of mainland China. The defeated nationalist government fled to Taiwan with about 2 million refugees. For decades, both sides claimed to be the legitimate government of all of China. Taiwan lived under constant threat of invasion. They were diplomatically isolated. Most countries recognized mainland China, not Taiwan. For practical purposes, Taiwan was a small, threatened island that nobody expected to succeed economically. But Taiwan had one critical advantage: American support. During the Cold War, the United States saw Taiwan as a strategic ally against communist China. America provided military protection and economic aid. This allowed Taiwan to focus on development instead of defense spending. In the 60s and 70s, Taiwan followed a path similar to South Korea. They started with low-cost manufacturing: textiles, toys, cheap electronics. Taiwanese factories produced goods for American and European companies wanting cheap labor. This brought foreign currency and jobs, but it wasn't sustainable. Taiwan's leaders understood that competing on cheap labor was temporary. Eventually, countries with even lower wages would undercut them. They needed to move up the value chain into higher technology. So Taiwan made critical investments. They funded education heavily, especially engineering and science. The government built technical universities and sent thousands of students to study at top American schools like MIT, Stanford, and Berkeley. Then they created incentives to bring that talent home: research parks, technology funding, university positions, all designed to convince Taiwanese engineers to return after studying abroad. By the 1980s, Taiwan had a generation of world-class engineers who had learned cutting-edge technology in America and brought that knowledge back. The government also created the Industrial Technology Research Institute, ITRI, in 1973. This government-funded organization focused on researching and developing advanced technologies. ITRI studied Silicon Valley and Japanese tech companies closely. They identified semiconductors as the future and decided Taiwan needed to enter the chip industry. But there was a massive problem. The semiconductor industry was already dominated by giants like Intel in America and Toshiba in Japan. These companies designed and manufactured chips in their own facilities. They had decades of experience and billions in capital. How could Taiwan possibly compete with these established powerhouses? That's when one visionary engineer had an idea that would change everything and create Taiwan's monopoly. In 1987, a 56-year-old engineer named Chang made a decision that would change the global technology industry forever. He founded Taiwan Semiconductor Manufacturing Company, TSMC, with a business model that had never been tried before, and that model would give Taiwan a monopoly on the world's most advanced chips. Chang wasn't from Taiwan originally. He was born in mainland China, moved to Hong Kong as a child, then came to the United States for university. He studied mechanical engineering at MIT and got his PhD from Stanford. Then he spent 25 years working at Texas Instruments, one of America's leading semiconductor companies, eventually becoming a senior executive. Chang understood the chip industry better than almost anyone, but in 1983, he was passed over for the CEO position at Texas Instruments. He was frustrated and ready for something new. That's when the Taiwanese government approached him with an offer. Taiwan wanted to build a semiconductor industry. They had invested in ITRE, trained engineers, and studied the market, but they needed someone with deep industry experience to lead the effort. They offered Chang the opportunity to build Taiwan's chip industry from scratch with full government backing. Chang saw an opportunity that nobody else had recognized. In the 1980s, every major chip company followed the same model. They designed their own chips and manufactured them in their own factories. Intel designed Intel chips and made them in Intel factories. AMD designed AMD chips and made them in AMD factories. This model made sense in theory, but it had a major problem. Building and running semiconductor factories, called Fabs, is incredibly expensive. A single advanced fab costs billions of dollars, and chip design requires completely different expertise than chip manufacturing. Companies were trying to do both and struggling. Chang had a revolutionary idea. What if you separated design from manufacturing? What if one company only manufactured chips designed by other companies? Design companies could focus purely on creating better chips without spending billions on factories, and the manufacturing company could focus entirely on perfecting the production process and serving multiple clients. This was called the pure play foundry model. And everyone thought it would fail. Why would companies trust their most valuable designs to an outside manufacturer? What if the foundry stole their intellectual property? What if quality wasn't good enough? The risk seemed too high, but Chang believed it would work if TSMC could prove they were trustworthy and technically excellent. In 1987, TSMC was founded with significant investment from the Taiwanese government and Dutch company Philips. Chang became CEO and set out to build the world's first pure-play semiconductor foundry. The early years were difficult. Convincing clients to trust TSMC with their designs was hard, but Chang made two critical promises that changed everything. Morris Chang's foundry model worked because he made two ironclad promises to potential clients. First, TSMC would never design its own chips. They would only manufacture chips designed by other companies. This meant TSMC would never compete with their own clients. Second, TSMC would protect client intellectual property absolutely. All designs would be kept strictly confidential. One client's designs would never be shared with competitors. These guarantees were revolutionary because they solved the biggest fear chip designers had about outsourcing manufacturing. Companies like Qualcomm, NVIDIA, and AMD could focus entirely on designing better chips without worrying about TSMC stealing their ideas or becoming a competitor. And it worked. In the early 1990s, small chip design companies started using TSMC because they couldn't afford to build their own fabs. A startup could design an innovative chip and have TSMC manufacture it without needing billions in capital for factories. This created an explosion of innovation. Suddenly, you didn't need to be a giant corporation to enter the chip industry. You just needed a good design and TSMC would manufacture it for you. Companies like NVIDIA, which started in 1993, built their entire business model around designing chips and having TSMC make them. NVIDIA never built a single factory. They focused purely on chip design and let TSMC handle manufacturing. The foundry model also had another massive advantage for TSMC. Because they manufactured chips for dozens of different clients, they could achieve enormous economies of scale. Their factories ran at full capacity constantly, making chips for multiple companies. This allowed TSMC to invest more in research and development than any single company could afford. While Intel had to fund R&D from selling Intel chips alone, TSMC funded R&D from manufacturing for Apple, NVIDIA, AMD, Qualcomm, and hundreds of other clients. The money poured in, and TSMC reinvested almost all of it into better technology. By the late 1990s, TSMC had become the dominant foundry in the world, but dominance wasn't enough. Morris Chang wanted TSMC to become so technologically advanced that no one could compete. So TSMC made a decision that would cement their monopoly. They would outspend everyone on research and development and always stay ahead in the race to build smaller, more powerful chips. TSMC committed to spending over 15% of revenue on R&D every single year. For context, that's higher than almost any other manufacturing company in any industry. In some years, TSMC spent over $4 billion on research alone. They hired the best engineers from around the world. They bought the most expensive equipment before anyone else. And they pushed the boundaries of physics to make transistors smaller and smaller. This relentless focus on being the technology leader meant that even when competitors tried to catch up, TSMC was already moving to the next generation. TSMC's dominance didn't come from luck or government protection. It came from outspending and out-innovating everyone else for decades. And the numbers are staggering. Between 2000 and 2023, TSMC spent over $140 billion on research and development and capital expenditures. That's more than the GDP of many countries. They built this massive lead by always being first to the next technology node. When the industry was making 28 nanometer chips, TSMC was already perfecting 20 nanometer. When competitors reached 20 nanometer, TSMC had moved to 16, then 10, then 7, then 5, then 3. Each jump required solving problems that seemed impossible. At 7 nanometers and below, you're dealing with quantum physics effects. Electrons start behaving unpredictably. Traditional manufacturing techniques stop working. TSMC had to invent entirely new processes. The most important breakthrough was adopting EUV lithography, extreme ultraviolet lithography. This is the technology that allows chips to be made at 5 nanometers and below. EUV machines cost over $150 million each. They're the most complex machines ever built. Only one company in the world makes them, ASML in the Netherlands. Each machine has over 100,000 parts and requires 3 cargo planes to transport. The mirrors inside are so precisely manufactured that if you scaled one up to the size of Germany, the biggest imperfection would be less than 1 millimeter. TSMC was the first company to adopt EUV at scale. They bought dozens of these machines before competitors could. Samsung tried to compete and bought EUV machines too, but they struggled with yield rates. Yield rate means what percentage of chips coming off the production line actually work. If your yield is 60%, 40% of chips are defective and have to be thrown away. TSMC consistently achieves yield rates above 90%. Samsung's yields were much lower, making their production more expensive and less reliable. Intel, the company that dominated chip manufacturing for decades, fell catastrophically behind. Intel had always made their own chips in their own fabs. But in 2015 and 2016, they struggled to move from 14 nanometer to 10 nanometer production. Technical problems delayed them for years. By the time Intel was making 10 nanometer chips in 2019, TSMC was already producing 7 nanometer chips in volume. Intel's CEO admitted publicly that they had fallen behind and would need to use TSMC for some of their own chip production. Think about that. Intel, the company that invented the microprocessor, now has to pay TSMC to manufacture Intel's chips because Intel can't do it themselves anymore. That's how far ahead TSMC is. China has tried desperately to catch up. The Chinese government has poured over $150 billion into semiconductor development. They've built fabs, they've recruited engineers, they've tried to buy equipment, but they can't get EUV machines because the Netherlands blocks sales to China under US pressure. And even if they could buy the machines, they're a decade behind in the expertise needed to use them effectively. By 2020, TSMC had achieved something almost unprecedented in modern business, a true technological monopoly. They manufactured 92% of the world's most advanced chips, not because of patents or legal barriers, but because no one else could do what they do. Let's break down exactly how dominant TSMC became. For chips at 7 nanometers and below, which are the processors that power iPhones, high-end computers, AI data centers, and advanced servers, TSMC has virtually no competition. Samsung can make 7 nanometer chips, but their yields are lower and their technology is behind TSMC's leading edge. Intel is still struggling to manufacture their own 7 nanometer chips reliably and has outsourced production to TSMC. Every other chip manufacturer is years behind. This means if you want the most advanced chip made, you have exactly one choice: TSMC. And this creates a lock-in effect that's almost impossible to break. Apple designs its own chips, the A-series processors in iPhones and M-series chips in MacBooks. These are some of the most advanced chips in the world. Apple is completely dependent on TSMC to manufacture them. Apple has tried to diversify. They've talked to Samsung, they've talked to Intel, but nobody else can make chips as advanced and reliable as TSMC at the volumes Apple needs, so Apple has no choice. NVIDIA, the company now worth over $3 trillion because of AI chips, doesn't manufacture a single chip themselves. Every NVIDIA GPU, the processors powering ChatGPT and AI systems everywhere, is made by TSMC. NVIDIA's entire business model depends on TSMC's manufacturing capability. AMD, Qualcomm, MediaTek, Broadcom, and hundreds of other chip companies are all in the same position. They design chips, but depend entirely on TSMC to make them, and switching is nearly impossible. It's not just about finding another manufacturer. These companies design their chips specifically for TSMC's manufacturing process. The designs are optimized for TSMC's technology, equipment, and techniques. Moving to another foundry would require redesigning the chip from scratch, which takes years and costs hundreds of millions of dollars. Even if a company wanted to switch, where would they go? Samsung is the only alternative for advanced chips, and they're behind TSMC technologically. Intel is trying to become a foundry and compete with TSMC, but they're years away from catching up. China would love to manufacture advanced chips domestically, but they can't get the equipment or expertise. TSMC's monopoly is also self-reinforcing. Because they manufacture for so many clients, they generate more revenue than any competitor. That revenue funds more R&D spending. More R&D keeps them ahead technologically. Being ahead attracts more clients. More clients mean more revenue. The cycle continues. In 2023, TSMC's revenue was over $69 billion. They're more profitable than most chip design companies despite being a manufacturer. And their market valuation exceeds $800 billion, making them one of the most valuable companies in the world. This monopoly makes TSMC incredibly powerful, but it also makes the entire world vulnerable, because TSMC's fabs are almost all located in one place, Taiwan. Here's where Taiwan's chip monopoly becomes a geopolitical nightmare. Almost all of TSMC's advanced manufacturing happens on one island that China claims as its territory and has repeatedly threatened to invade. This creates the single most dangerous economic vulnerability in the world. China has never recognized Taiwan as an independent country. The official position of the Chinese government is that Taiwan is a breakaway province that must eventually reunify with mainland China. And Chinese President Xi Jinping has made clear that reunification is a core national goal that China will pursue by force if necessary. China conducts military exercises around Taiwan regularly. Fighter jets cross into Taiwan's air defense zone. Warships patrol the Taiwan Strait. Chinese state media publishes invasion scenarios. This isn't theoretical posturing. U.S. military analysts estimate that China could have the capability to invade Taiwan by 2027. Now think about what happens if China actually invades. Taiwan produces 92% of advanced chips. If those factories stop operating, every tech company in the world loses access to the processors they need. Apple can't make iPhones. Nvidia can't make AI chips. Car manufacturers can't get the chips for vehicle computers. The entire technology sector grinds to a halt within months. The economic damage would be catastrophic. Estimates suggest a Taiwan conflict would cause between $5 and $10 trillion in global economic losses. That's larger than the entire GDP of Japan. Stock markets would crash. Supply chains would collapse. The world hasn't seen economic disruption on this scale since World War II, but it gets worse. TSMC's factories are incredibly fragile and complex. You can't just shut them down and restart them later. Semiconductor fabs require continuous operation. The clean rooms must maintain perfect environmental conditions. The manufacturing process runs 24 hours a day, 7 days a week. If operations stop for even a few weeks, the equipment degrades and contamination ruins the facilities. If China invades and TSMC's factories are damaged or shut down, it could take years to rebuild that manufacturing capacity. And here's the nightmare scenario that keeps U.S. military planners awake at night. If China controls Taiwan, they control TSMC. And if China controls TSMC, they control the global chip supply. China could cut off advanced chips to the United States and its allies. American tech companies, military systems, everything that depends on advanced semiconductors would be at China's mercy. This is why the United States has committed to defending Taiwan militarily if China invades. It's not just about democracy or alliances. It's about preventing China from gaining control over the most critical technology supply chain in the world. Taiwan has become what some analysts call the most dangerous place on Earth. A small island that both superpowers, the US and China, consider vital to their interests. And the reason it matters so much is because of those semiconductor factories. TSMC didn't just make Taiwan rich. They made Taiwan the center of global geopolitical tension. The entire world economy is now hostage to what happens on this one island. The United States government finally realized they had a massive problem. America, the world's largest economy and military superpower, was completely dependent on chips made in Taiwan, an island under constant threat from China. This was a national security crisis. So starting in 2020, the U.S. launched an aggressive campaign to reduce dependence on Taiwan and rebuild domestic chip manufacturing. The strategy had two parts: convince TSMC to build factories in America and pour massive government funding into reviving the U.S. semiconductor industry. In 2020, after intense pressure from the Trump administration, TSMC announced they would build a $12 billion fab in Arizona. This was a huge deal. TSMC had never built an advanced manufacturing facility outside of Taiwan before. The Arizona fab would manufacture 5-nanometer chips, not the absolute cutting edge, but still extremely advanced. Then in 2022, the Biden administration passed the CHIPS Act, a $52 billion package of subsidies and incentives to bring chip manufacturing back to America. TSMC responded by expanding their Arizona plans. They committed to building not just one fab, but 3 fabs in Arizona with total investment exceeding $40 billion. These facilities are scheduled to start production in 2025 and 2028. Intel also announced plans to build multiple new fabs in Arizona, Ohio, and New Mexico with over $100 billion in investment. Samsung said they'd build an advanced fab in Texas. The U.S. government was trying to create an entire semiconductor manufacturing ecosystem on American soil. But there are serious problems with this plan. First, building fabs in America is incredibly expensive. The same factory that costs $12 billion in Taiwan costs over $20 billion in Arizona. Why? Labor costs are higher. Regulatory requirements are stricter, construction takes longer, and the U.S. lacks the ecosystem of suppliers and skilled workers that Taiwan has built over decades. Second, TSMC is struggling to replicate their Taiwan success in Arizona. They've faced construction delays. They can't find enough skilled workers. Taiwanese engineers sent to Arizona to train American workers have complained about work culture differences. TSMC is used to engineers working extremely long hours with intense focus. American workers expect better work-life balance. This has created tension and delays. Third, even if the Arizona fabs succeed, they'll only produce a small fraction of what TSMC makes in Taiwan. The 3 Arizona fabs combined will have less capacity than TSMC's largest single facility in Taiwan. The U.S. will still depend heavily on Taiwan for chips. Fourth, these fabs won't be operational for years. The first Arizona fab might start limited production in late 2025, but reaching full production will take until 2027 or later. If China invades Taiwan in the next few years, those Arizona fabs won't help. And fifth, moving chip production is extremely difficult. It's not just about building factories. You need the entire supply chain and the specialized chemicals, gases, and equipment suppliers, skilled technicians, all located nearby. Taiwan has spent 40 years building that ecosystem. You can't replicate it in America in just 5 years. The reality is that even with tens of billions in subsidies and TSMC building in Arizona, the US will remain heavily dependent on Taiwan for advanced chips for at least the next decade. So what can we learn from Taiwan's semiconductor dominance? And can this monopoly actually last? Let's start with what Taiwan did. Right. First, they identified a critical future technology early. In the 1970s and 80s, Taiwan's government recognized that semiconductors would be essential to the future economy. They made a bet and committed fully to that sector. Second, they invested massively in education and brought talent home. Taiwan sent thousands of engineers to study at the world's best universities, then created incentives to bring them back. Morris Chang himself was a product of this strategy. Third, they found a revolutionary business model. The pure-play foundry model that Morris Chang invented didn't exist before TSMC. By separating design from manufacturing, TSMC created an entirely new industry structure that unlocked massive value. Fourth, they committed to relentless R&D spending. TSMC spent over 15% of revenue on R&D every year for decades. This kept them ahead, technologically, even when competitors tried to catch up. And fifth, they maintained focus and discipline. TSMC never tried to design their own chips. They never diversified into unrelated businesses. They did one thing, manufacturing chips for others, and became the absolute best at it. But can this monopoly last? There are serious challenges ahead. The biggest threat is geopolitical. If China invades Taiwan, TSMC's dominance ends immediately, either through destruction, disruption, or Chinese control. Even without invasion, the constant tension makes clients nervous about depending entirely on Taiwan. The second challenge is diversification pressure. Governments around the world are pushing to reduce dependence on Taiwan. The US CHIPS Act, Europe's semiconductor initiatives, Japan's Fab subsidies, all aim to build domestic capacity. This will slowly reduce TSMC's market share. Third, technology is approaching physical limits. As transistors get smaller, you eventually hit the limits of physics. TSMC is already at 3 nanometers. Going to 2 nanometers and below becomes exponentially harder and more expensive. At some point, the pace of advancement will slow. And fourth, competition is intensifying. Intel is investing massively to catch up and become a foundry. Samsung continues pushing. China will eventually develop advanced capabilities even if it takes decades. TSMC's lead will narrow over time. But here's my assessment. TSMC's monopoly will probably last another 5 to 10 years at current dominance levels. They're too far ahead technologically and have too much momentum. But by 2035, I expect TSMC's share of advanced chips will drop from 92% to maybe 60 or 70% as other fabs come online. The lesson for other countries is clear. If you want to build a world-leading industry, you need long-term vision, massive R&D investment, world-class talent, and relentless execution over decades. Taiwan did all of this. But Taiwan also shows the danger of monopolies and geographic concentration. The entire world economy shouldn't depend on factories located on one threatened island. That's a systemic risk we're now trying desperately to fix. If you want to see another story of strategic industry dominance, check out my video on how South Korea went from war-torn to creating Samsung, Hyundai, and global manufacturing power. The link is in the description. If you found this valuable, hit the like button and subscribe, because we're breaking down the economic and geopolitical strategies that shape our world. See you in the next one.